Welcome again to the classroom, and today I will solve the IB probability math problem on the hypothesis testing. But before solving, I will briefly explain what is hypothesis testing, null hypothesis, and the alternative hypothesis. And also, I will explain regarding one sample or two sample test. As test can be either one-tailed test or can be two-tailed test. So we will see also regarding that. Also, we will see in brief which appropriate test statistic you should employ whenever given the hypothesis testing problem. We know for sure we have varieties of test statistics. We have t-test, we have z-test, we have f-test, chi-square goodness of fit test, and the other tests of the same reflection. So we will see which test statistic exactly we need to employ whenever given the hypothesis testing problem. Also, we will see the algorithm on how to plug our sample values, our given sample values, on the Texas instrument, TI-84, and to get the p-value. As for sure, the p-value is the one which determines whether to accept or to reject the null hypothesis in comparison with the level of significance. And thereafter, upon having the p-value, after plugging our sample values in the calculator, then we will see how to draw a meaningful statistical conclusion based on the given problem. So let us start. So, first, what is hypothesis? Maybe asking. Let us start by the meaning hypothesis. Hypothesis, we are saying this is the assertion. The hypothesis is the assertion and forceful statement that something is true. That is the hypothesis. The hypothesis is the claim. Is the claim related on something. For example, the manufacturer of drugs claims that the new drug is 80% more efficient than the previous drug. Or the manufacturer of products claims that the performance of the product A is more useful than the performance of the product B. So that is the claim. That is the assertion. So from the assertion, from the claim is where we get the hypothesis. So all the IB questions related to hypothesis testing on the given problem, on the first part, initial part of the problem, the explanation is where we get the assertion, is where we get the hypothesis. So, for example, that A maybe, I said maybe a manufacturer claims that the new drug is, the effect of new drug is 80% more useful than the previous one. So here our hypothesis, which is H, we can say the probability is greater than 0.8. So from this assertion is where we get the null hypothesis, HO, and the alternative hypothesis, HA or H1, whatever you might call it. So here, our null hypothesis means the probability will be less than 0.8, and the alternative hypothesis, this one less than or equal, and the alternative hypothesis is the probability is greater than 0.8. For example, where I said the assertion on the product A and B, manufacturer claims that the product A, the performance of the product A is much better than the performance of product B. So here our hypothesis, we can say the mean of the product A is greater than mean of the product B. So from there is where we are getting the null hypothesis, which we are saying H0. We are saying mean of A is less or equal to the mean of product B. And the alternative hypothesis here can be mean of the product A is greater than the mean of the product B. So here what I'm trying to say, the claim is always the assertion. The claim is always the alternative hypothesis. The null hypothesis indicates that no difference, indicates that no changes. But the alternative hypothesis indicates that there is change. And always the null hypothesis is stated in negative way. It goes against the claim. So the alternative hypothesis, which is also known as the research hypothesis, this is the one which goes exactly with the claim. So this is how the null and the alternative hypothesis, the null and the alternative hypothesis is. We will see in detail on the given problem. Also, the hypothesis can be one-sided, and also the hypothesis can be two-sided. The two-sided is where we have two-sided sample tests. We have two sample T tests, two sample F tests, and one-sided hypothesis. So one-sided hypothesis is like, for example, here you are given mean of product A is greater than mean of product B, and the two-sided is mean of product A is not equal to the mean of product B. Wherever you see not equal, this indicates that this is the two-sided hypothesis. So if we are going direct to our given problem, it is saying that we have Miss Calhoun measures the height of student in her mathematics class. She is to see if the mean height of male student, which she call it mu1, is the same as the mean height. This one should be of female student, and she call it mu2. The information is recorded in the table. On the given table, we have the male height in centimeter, and we have the female height also in centimeters. The question is continuing by saying, at the 10% level of significant, a t-test was used to compare the means of the two groups. The data is assumed to be normally distributed, and the standard deviation are equal between two groups. Okay, so part A of the question, it says state the null hypothesis. Of course, this is very simple. How do we state the null hypothesis? Here we do state the null hypothesis by saying the mu1 goes to mu2. The alternative hypothesis. What is the alternative hypothesis? This is always goes against the claim, because the claim says that the data is assumed to be normally distributed, and the standard deviation are equal between the two groups. So the alternative hypothesis, we are saying mu1, this is not equal to mu2. Part B of the question, it says calculate the p-value of this test. So in calculating the p-value, let us plug. This is our calculator. We have it here. So let us switch it on. We are going here to start. Then we are saying edit. Okay, then we plug our values of L1. Here it is 150, 148, 143, 152, 151, 149, 147. And also we have the female height also should be plugged. The female height, it starts with what? Oh, where does this come from? No way. This number is not supposed to be there. We have 148. Why that 5? Where does this 5 come from? Oh my God. That can't be. So let me delete. Come here. So, okay. Come here again. Say delete. Yes. So it is 148, 152, 154, 147, 146, 153, 152, then 150. So we have our L1 and L2. Then we are coming here to start. Then we are finding the test. We have Z test, we have T test, 2 sample Z test, 2 sample T test. Why 2 sample T test? Because on the question here we have been given directly, we have been asked direct here to use the T test. And since we have 2 samples, sample 1 and this sample 2, so obviously we have to go with 2 sample T test. So then we are pressing here enter. Input data, fine. Then we have list 1 is L1, list 2 is L2. Always the frequency value here in the place of frequencies. Here F1 always is 1, and here F2 is always here 1, 1. So, and here there is something important. mu1 such that not equals to mu2, less than mu2 or greater than mu2. Here we are saying not equals to mu2. We put our alternative hypothesis. And here is the part where most of the students are confusing. Pooled. Whenever you see the word pooled, and here there is yes or there is no. So at what time we have to say yes, at what time we have to say no. So if we read the question properly, we observe the question properly, there is this statement here. It says the standard deviation are equal between the two groups. So since the standard deviation are equal, then the pooled, we are saying yes. If the standard deviation are not equal, means the pooled, we are saying no. If we said yes, it means the calculator will find the combined standard deviation between the two samples using this formula, SP square, the pooled variance equals to M1 minus 1, then S1 square, U plus N2 minus 1, then S2 square. This we divide by N1 plus N2 minus 2. So this is the formula for pooled variance. For the pooled standard deviation, we just square root that much is SP, but everything is done by calculator. So no need for you to bother yourself with these calculations. So in the place of pooled, there we are saying yes. Why are we saying yes? Because we have been told that the standard deviation between the two. Why are we saying yes? Because we have been told that the standard deviation between the two groups are equal. So then after saying yes, what next? We calculate. After calculating, we are getting all important values. We are getting t-value, we are getting p-value, we are getting degrees of freedom, mean, and stuff like that. So what have we asked? We have been asked for the probability value, p-value. So our p-value from the problem is 0.2957. If we do approximate, it is 0.29, then 6. Our alpha, what is alpha? Alpha is level of significance. Our alpha is level of significance. What is level of significance? Is 10%. That means it's 0.1. So we compare between the level of significance and the probability value. So here we see that 2.296 is greater than 0.1. That means the value, the probability value, the p-value, is greater than the level of significance. Since the p-value is greater than the level of significance, we conclude by saying we reject, we fail, not we reject. Oh my God, what am I doing? We are saying we fail to reject H0. That means we fail to reject the null hypothesis. So, to show the maturity, to show that you have wider mathematical knowledge and you have understood what have been asked, you can conclude by saying, after saying we fail to reject H0, you can add by saying and conclude that the mean height between the two groups are the same or are equal. So we failed to reject H0. Why have we failed to reject H0? because we don't have sufficient evidence. And we conclude by saying that the mean height between the two groups are the same. So this is how you are supposed to attempt the question related to hypothesis testing. You need to be very carefully on plugging your sample values in calculator. You need also to be carefully on choosing the appropriate test statistic to use. You need also to be carefully on drawing conclusion based on the p-value obtained after plugging your sample values. So up to there, thank you very much. See you in next video and happy learning.